Hello everyone, and welcome back to the garage. Today we're going to get started on another pinball restoration series, this time for a 1978 Williams Phoenix pinball machine. If you haven't seen my last video, I ended up getting two more pinball machines, this Williams Phoenix and a Gottlieb Close Encounters of the Third Kind, both of which have been sitting since the 80s and need a lot of restoration work. So we're going to start with the Williams Phoenix because I'm more familiar with the Williams board set that is used in these late 70s games, and I think I can get it going pretty quickly. So let's get started. So here is the Williams 1978 Phoenix pinball machine. I already did a little bit of cleaning on this machine beforehand. The glass was covered in dust, so I wanted to get that a little bit cleaner before we started. I vacuumed out the inside of the cabinet. I had the Playfield open. I vacuumed out all the cobwebs that were on the Playfield, but other than that, I haven't really done any cleaning or any sort of maintenance to this machine at all, other than drilling out the coin door lock, because the key that was in it, no matter how much lubricant I put in that lock, it would not budge. So we drilled out the lock, got access to the coin door so I could open up the Playfield, and the lock for the back box was already unlocked, so I was able to get behind there and take a look. We do have a little bit of battery leakage on the MPU board that we're going to have to deal with before I plug this machine in. It didn't damage too much, so I'm pretty confident that we can get this machine going pretty quickly after we fix that and do some testing. But before we do any of that, both this machine and the Gottlieb Close Encounters of the Third Kind have a very strong mold smell when the machine is open. So we're gonna have to do a lot of cleaning on this thing, and that's something that I wanna do first because I don't wanna work on this machine and have to smell that smell constantly. So I'm gonna go ahead and get this machine cleaned up a little bit. And as you can see, the Playfield and the plastics are kind of just covered in dirt. They're not very shiny at this point, as you can see. Got a lot of dirt there because I think you should be able to see through that. You can just see everything's kind of just coated in dirt because this machine's been sitting for 40 years, so that's to be expected. So I'm gonna go ahead, get the glass off, and we'll start doing some cleaning. All right, I'm gonna give you a good look at the Playfield before I do any sort of cleaning, because this is going to be a huge undertaking, and I'm probably gonna have to remove all of the plastics in this thing just by taking off the nuts and the screws and just removing those. And I'm not gonna do that on camera, so I'm gonna give you a good look at the Playfield before I do any cleaning to it. So you can see that's how it looks right now. Okay, I went ahead and took all of the plastics off the Playfield, and you can kind of see now the sorry state of all the rubbers in this machine. I went ahead and ordered a rubber kit for this machine, so I'm going to be replacing all of these very soon. You can see how dirty the Playfield is where the plastics were at. I didn't take the bumpers off yet. That's something I'm gonna do. But when I did take the plastics off this machine, I found a couple things that are wrong. This bumper is a little bit loose, so I imagine I can just go under the Playfield and tighten it. These two are tight, but obviously this one needs a little bit of tightening. And it's not the cover that's loose, it's the entire bumper. So we'll have to investigate that. And this target is also completely loose. And that was one of the rivets that, I think they're rivets that just fell into the machine. This is supposed to be held on, this metal piece is supposed to be held on to the actual target, but the actual things that hold it on have come loose. So we'll have to go under the Playfield and fix that target before we end up trying this machine out for the first time. I still have to take off these plastics. I haven't done that yet. I just wanted to get all the big plastics off this thing. And I set up a little table here to start going through and cleaning these things. Here's the bin full of plastic. You can see this is what a dirty plastic looks like. You can see the amount of dirt buildup on that. And then underneath, this one's not the worst plastic. Let me look at this one. You can see the underneath of these plastics has some mold on them. Well, I went ahead and cleaned up this plastic. Look at how good it turned out. There is not one scratch on this plastic. All that dirt buildup came right off with a Clorox wipe. And I also went ahead and wiped down the underside, and that looks a ton better than when it started as well. This thing had so much mold on the bottom of it, and now it's basically all gone. So these plastics are gonna come out looking really nice when I'm done. So I'm gonna go ahead and clean the rest of these plastics, and then I'll go ahead and start wiping down the Playfield, vacuuming up all the crap that's back here. I'll take some more of these little plastics off, give those a clean, and then before we put the plastics back on, I'm going to replace the rubbers once my rubber kit arrives. And I think I have enough spare warm white LEDs that I can use to replace these bulbs. You can see how many of them are dark. They've darkened really badly over the years. So that one's okay, but you can see that one's super dark. A lot of these have turned dark. So I think I have enough spares to convert most, if not all, of the upper Playfield lighting to warm white LEDs. So I'll go ahead and throw those in there just for now to see how it looks. And I'll update you as things keep going on. All right, I finished cleaning all of the plastics, and as you can see, they all turned out super good. A lot of them had mold on the back. There was nothing Clorox disinfecting wipe couldn't fix. So now these things look basically brand new, and they no longer have mold on them. As far as the pinball machine goes, I went ahead and cleaned up the yellow bottom plate here, and it looks fantastic, as you can see. I gave the Playfield a little bit of a wipe, and so it looks a little bit better. I went ahead and I pulled off most of the old rubbers on this machine, and I did that at exactly the right time because all of these rubbers want to stick to the posts that they're on. So if I waited any longer, parts of the rubbers would probably have permanently stuck to the post. So I'm getting to these rubbers at exactly the right time. I've come to the conclusion that to get all of the mold and other dirt off the Playfield, I'm gonna have to essentially strip it all down. So that's gonna mean taking off all of these posts and taking off the rest of these plastics, getting the remaining rubbers that I haven't gotten yet, just taking a lot of stuff off the Playfield so that I can get to the mold and clean it up. And another thing that I found is that the flippers in this machine are very loose. So obviously something needs to be tightened in where the flippers are, or this thing needs a rebuild kit. And I think I have a late 70s Williams rebuild kit. I'll have to look. But before I go that route, I'll see if I can get these tightened, because I think the coils are fine. It's just something is obviously very loose with those flippers. So things are going well so far with the cleaning. I also went ahead and I removed all the bulbs from the upper part of the Playfield except for the bumpers. I haven't taken those off yet. There was only one bulb out of all of the bulbs in the Playfield that was actually not dark at all and still good. All the rest of them were dark, so I threw them all away. So we're kind of doing this machine backwards, aren't we? We're doing the rubbers and the LEDs first before actually testing the machine to see if it works. And that's simply just because of the mold and how filthy these things are. It just requires me to clean it up first, and I figure that while I have all the plastics off and I'm doing all the rubbers, I might as well go in and do the LEDs as well so I don't have to take it apart again. So I'm gonna go ahead and keep stripping this thing down, and I'll come back to you once I have an update. Okay, I did a little bit more work here. I took off the bumper plastics and took out the bulbs that were in there. One of them was dark, two of them were actually perfectly good bulbs, so I decided to save those. I still have to take off some rubbers and plastics still, but what I want to do right now is see if I can solve the problem of this bumper being loose and this target being extremely loose. So inside the bumper, there are two screws that secure this white part of it down, and no matter how much I tighten those screws, it does not tighten the bumper. So I'm gonna go ahead and open up the Playfield and we'll see if maybe there are some nuts on the backside that have come loose. So after looking under the Playfield a little more, those two screws on the top of the bumper, they are not part of any of the bumper assembly that is underneath the Playfield. So I think what's happening is those two screws, the threads that they're in are completely stripped because the screws won't tighten and the bumper is still loose even after I try to tighten them. So I don't think the problem is under here, but I also do want to show you that drop target because we do have an identical drop target on this thing that is good that we can compare it to. So up here on the top left of the Playfield, we have a drop target here that is working just fine. So if we look at that, you can see it's mounted right there. And if I push the target, you can kind of see the switches getting pressed. So this is how the target is mounted to the system. We have two rivets right here. And these are the other ends of the rivets. And then this is the switch assembly in between those. And then that whole assembly gets screwed to the Playfield. But if we look at the other one, here's the other drop target right here, and you can kind of see what's happened. So the little metal bracket is still screwed into the Playfield, and the rear parts of the rivets are still on, as you can see, but the rivets have just broken off. So as you can see, they're kind of just loose in there, and so that's why the drop target's loose. So I'm gonna have to figure out how to secure that assembly back on, whether that's super gluing the rivets back in or using screws. I'll have to figure out a way to fix that. But it doesn't look like it's gonna be a very complicated fix because the whole assembly is still there, so that's good. So I don't think that'll be a super complicated thing to fix. All right, so after finding out that the rivets would actually still go into their holes somewhat, I decided to just super glue them back in like that. So I went on the inside of the rivet and just super glued it against the metal. So once that dries, the drop target on the right should be nice and tight again. So that's one problem fixed. All right, I've gone ahead and essentially stripped almost everything off the Playfield, and this is as far as I'm gonna go with that. As you can see, I've removed almost everything, and that's just because I need to get access to all the nooks and crannies to clean all the dirt and mold out of this thing. So I left the bumpers in because those don't need to come out, but I took almost everything else out. I took all the red posts out. All the rubbers have now been removed. And so now this Playfield is ready for me to give it a deep clean, get all the mold and dirt out. And once my rubber kit arrives, we'll start putting it back together, put all new rubbers in place, and I'll put LEDs in the upper Playfield, just warm white LEDs for now, and then we'll go from there. You can see my parts area has accumulated quite a lot. I've sorted out the screws and all the different pieces, so I know what goes where. Plus I took some pictures of the Playfield as I was disassembling it. So it'll be no problem for me to put it back together. But one other thing I am gonna have to do is take off the yellow plate here along with the one on the plunger, because you can see there's mold underneath it too. So I'm gonna have to remove that as well, and then we can clean the Playfield, get some warm white LEDs in it, new rubbers, and then we can start messing with the backboard and the battery leakage, do some testing of different components, and then at that point, we'll be able to plug this thing in and see if it still works. So I'm gonna go ahead and give this a clean. All right, I've given the Playfield its first proper wipe down, and as you can see, it looks a lot better now. Most of that black stuff, the mold, is gone, and it overall just looks a lot better. So now at this point, I'm gonna take off this panel, take off the one for the plunger, and we'll clean up the mold out of there. All right, so that's what it looks like underneath those two panels. You can see all the mold that I was talking about. And so we're gonna have to clean all of this up. I removed the bulb that was here. This bulb lights up a little white circle on the yellow panel, and all that does is just indicate that there are credits in the machine. It does tell you how many credits are actually in the machine with the display right there, but this light will also light up too when there's at least one credit. So I think what I'm gonna have to do is remove the entire ball loading mechanism here just because of all the mold that's under it. And I'm also gonna have to fix the ball return switch, because what happens is the ball comes down here and it should push down on the switch, and the little thing that it pushes on is way too far down. So I'm gonna have to adjust that switch, because that's a very important switch to have correct, or else you won't get any additional balls after ball 1. And you won't be able to end the first ball. So I'll adjust that switch. This coil seems like it's just fine. Don't see anything wrong with it. But I am gonna have to take all this off just to get to all the mold, clean it out. And then after that, the entire upper section of the playfield here should be nice and clean, because I went ahead and did all of this already. So I'll go ahead and get to that and take all this stuff apart, and we'll go from there. So I've been starting to clean underneath here, and as you can see, this is the difference between a cleaned up side and a non-cleaned up side. So you can see all the mold and dirt buildup that's here. So I'm gonna go ahead and clean the rest of this, and then I'll start putting the metal ball return mechanisms and pieces back on. And there's what the right side looks like after I gave it a complete cleaning. As you can see, it looks a million times better. I even went ahead and removed the ball loading coil. I just took the whole assembly off and just cleaned underneath it so there was no mold. And it's a good thing I did that, because there was mold under it. So I took everything off, cleaned it up, and now everything looks nice. Now I just have to clean up the pieces that I took out from that assembly. They're kind of scattered on the table here. And then I'll put this whole assembly back together, and then we'll see how it looks. All right, I fixed the out hole switch for the bottom, and I had to refer to the schematic just to make sure that the switches were in the right position, and they were not. So what was happening is, you see how the metal part comes down and makes those two switches close? Well, the metal part was in front of these switches instead of behind them, so it didn't have enough spring force to come back up like that. So now the out hole switch is working, and so that's another problem solved. Here's what it looks like before the metal piece goes back on, and this is what it looks like after the metal piece is back on. As you can see, it looks a ton better. And if you look under here, you can see I put a little cool white LED in there. I figured I might as well do that now while I have the piece apart. All right, well, I just discovered something else about this playfield and how I can get it to look even better than how it does now. So if you look right here at this yellow flame right here where it says Phoenix, you see how there's a little bit of dirt in the flame? Well, if I use a magic eraser, I used it on this spot right here, look how clean it makes it. So now I'm going to have to use magic eraser throughout the entire playfield, and I tested it on some of these dirty spots where the mold residue is now, and you can see right here is a spot that I magic erased. So obviously the magic eraser is going to be able to get residue like this off. So now what I'm going to do is do the whole playfield with the magic eraser, and it is going to look absolutely amazing by the time I'm done doing that. I also went ahead and I cleaned off the white bumper switches here, so now those look really nice. So now I have another cleaning journey to do. I'm going to wipe this whole thing down with a magic eraser. So I'm going to give you another good look at how it looks now. I'll kind of go closer in this time just so you can see the level of dirt on the playfield right now. It's not terrible, but with the magic eraser it will certainly look a lot better. So I'm going to go ahead and do that, and then I'll show you how the playfield looks after I'm done with that. All right, I have magic erased the entire playfield, and I think it looks way better, a lot more vibrant and shiny. So that is how the playfield looks now. I did magic eraser in the spots where there was still residue from the mold underneath where the plastics were. And so now most of that is gone. And I think the playfield turned out really well in this thing. This is as clean as it is going to get, and I think it looks amazing. And while I was cleaning the playfield, I also super glued the rivets back together on this target. And so now it is nice and solid again. It doesn't move forward and backward all loose like it was doing before. And the target actually works now. So this target is all fixed. So now at this point, the playfield is ready for me to put LEDs in it. I'm gonna start cleaning up all of the pieces that I took out. These are just all the little plastic pieces that were removed from the playfield. Clean up some of these other metal pieces, clean up that piece, and then after that, my rubber kit will probably be here, and then we could start putting the playfield back together. And my luck couldn't have turned out any better with the LEDs. I had just enough spare LEDs to do the entire upper playfield of this game, except for the bumpers. So for now, I just put some incandescent bulbs back in there. So obviously at some point, I will convert this entire machine to LEDs. And I don't know if I'm gonna leave it as all warm white LEDs. Maybe I wanna put in some colored ones, I'm not sure. But I had exactly enough spare warm white LEDs to do the upper playfield here, as you can see. So that is another thing done with this machine. Now I'm gonna go ahead and start cleaning up some of the stuff, and we can start putting the playfield back together. Well, I figured I would put the pop bumper plastics back on because there's no reason to not put them back on. So I cleaned them up and put them back on, and now they look a little better. But I wanted to fix the issue with this bumper where it was loose. So I looked under the playfield to see what was loose, and it was actually nothing under the playfield, but it was just the two screws that screwed into the wood that were loose. The threads that were in the wood were completely stripped out, and you were able to move the bumper as a result. So what I did to fix that problem is I found two bigger screws. They're the same size, just thicker, to screw into those holes so that they would go against the wood again. And now that bumper is as tight as can be. So that issue is now fixed. And when I was putting these screws in, I kind of had to bend this light socket out of the way because, as you can see, the screw heads, they are very thick, so I had to move this out of the way while I was putting those in. But it worked out perfect, and the screws now tighten, and the bumper is now nice and tight. So that's another problem that has been fixed. So I opened the playfield just to make sure that the screws I put in didn't go through the cabinet, and they don't, which is good. I was taking a look at some switches, and I noticed that the left in-lane switch right here is not working because when I push it all the way down, it does not hit the switch. It doesn't close. So I'm gonna have to adjust this bottom switch right there. All right, I went ahead and adjusted that. So now that switch is working. So if I put my finger over it, you can see now it actually hits the switch and closes. So that is how that's supposed to work. I checked all of the other in-lanes up here, there, and on the other side, and they're fine. I still have to check the in-lanes down here, and if those are out of adjustment, I will adjust them. So I would have eventually found that problem when we turned the game on and we did some switch testing. I would have pushed this down and nothing would have happened. So I would have eventually found that, but it's good that I found it now because then we won't run into that problem later on. So I'll go ahead and check the rest of the switches. All right, so while we wait for the rubber kit to arrive, the next thing I want to do is work on the coin door because, as you can see, it's quite dirty and we have some work to do in here before I want to turn the machine on. And that's specifically because I noticed that the coin switches are not in the right position. They should be up here, up toward the top like that. And when you push them down, they want to stay down. And that's because if you take a look inside here, you can see they're attached to a little assembly right there, and that assembly is not the right spot. Because what should be happening is when this switch goes down, it should be closing the switch that's in here so the game knows that you just put in a coin. And both of them have the same problem, so we're gonna have to disassemble this coin door a bit and see if we can get some stuff fixed and cleaned. So the first thing we can do to free up some more space in the coin door is to remove the actual coin mechanisms. And on these Williams machines, it's pretty easy to do that. So all you have to do is pull back on this little bracket right here. This is what keeps the coin mechanism in. So if you pull that back, you should be able to pull the mechanism right out. And there we go. Very simple. There we go. That one took a little fiddling. That one was kind of stuck. But there we go. Now we got the second one out. And now we indeed know this machine came from Canada. Both coin mechanisms say Canada on the back. So this machine originated from outside the US. So now that those are out, we can take out these little yellow plastic pieces and take a look at the switches that are inside them. So here you can see one of the coin door switches, and how this should work is this should be spring loaded. So when this goes down, it should shoot right back up when the coin hits it. And obviously it's not in the right position to do that. And as you can see, it's not even closing the switch. So what I think needs to happen is the spring itself, the part that the coin hits, should be in there, like that. Oh, that was literally it. Okay. Yeah, that works now. As you can see, now it spring loads itself and it hits the switch closed. So that is entirely it. And taking a look at the second switch and comparing it to the one on the other side, it's apparent that all we need to do is just shift this little white part down a bit, and now it will spring load. So now closes the switch. That one might be out of adjustment. You see how the switch on this one is always closed? That should not happen, so I need to adjust that switch a little bit. And there we go. Now the switch is open, and now when the coin hits it, it closes the switch properly. So there we go. Both of the coin mechanism credit switches are fixed. And so now when you put in a coin, it will actually give you a credit like it's supposed to. So now what I want to do is get behind here so I can take out the price signs and clean inside there. So to do that, it's pretty easy to get in there on these late 70s Williams coin doors. All you have to do is take out these 3 screws right here on the top, and then this whole thing kind of hinges down. And then once you take out the last screw, this bracket will come out with it, so you want to take that out as well. And so now that those are off, this thing will just hinge down. It might be a little bit stuck, but we'll see if we can get it to move. There we go. There we are. And I saw this. We have a third price sign in here, but it's not being used. So I'm gonna go ahead and take that out. It's got a big crack down the middle, so obviously that is no longer a good price sign. And it looks like to get this metal plate off, it's just these 2 screws right here. So now with those out, this should just lift right out, and it does. And so now we have access to the price signs. And you can see how rusty this piece is. That is pretty filthy. This one is cracked in half almost. And there's more proof that this came from a different country than the US. 1 spell, 6 franc. And then here's the other quarters sign, just as filthy. And to get these little plastic pieces out that the coin travels through, they just pull out once you have the sign removed. So those are easy to pull out. So now I'll go ahead and clean all of these signs up. Clean out this entire coin mechanism. There's another sign in here actually. And I noticed that it was in upside down. This is just a little plaque that has the Williams logo on it. It's upside down right now. It should be like this. And then also there are these 2 metal pieces in there that can get removed as well. So those are out, they're all rusty. And so now that assembly is all taken apart. And if you want to remove this piece, all you have to do is take out these 3 screws, and then this hinged piece can come out. And then to remove the actual hinge, there are 3 more screws there, and then the hinge will come out. So that's how you disassemble one of these Williams coin doors. And as you can see, both bulbs here are extremely dark, so those are going to get removed. So I'm going to clean up this coin door. It's pretty bad, and it's got mold in places, like some right here next to the buttons. It looks like maybe there's liquid damage on some of the metal pieces in here. It doesn't look too good. All right, a closer inspection, it looks like I can remove all the internals of the coin door in one piece. So what I need to do is take out the screws along the bottom of this part here, and then there's 3 more screws on the top of this plate right here that have to come out. And then I'll have to undo the lamp sockets as well as a couple ground wires. And then I think I should be able to pull this whole thing out. Now, it is connected inside the machine, but it's got a connector on one end. So I'll actually be able to remove that connector and then take the whole assembly completely out. But in order to remove the wiring, it's got a little metal bracket on the inside of the machine that's just held in with a screw. So after I unscrew all that, I should be able to get this entire thing out and then really take the coin door and clean it up. So I'm gonna go ahead and do that. And there we go. There are the internals of the coin door now out of the machine. All right, I cleaned up all these pieces as best as I could. As you can see, there's still some here that have rust on them. I just wanted to get them clean. I'm not gonna be too worried about the rust right now. I'll probably take apart this coin door again and make everything look nice in the future. For now, I just wanted to clean the stuff up, get the mold off especially, so things look a little bit better. Now there's no more crazy mold on the sticker. There's still a little bit of spots, but nothing like it was before. This machine obviously had some sort of liquid damage by the coin door at some point, because as you can see, there's a lot of damage to the metal inside the door there. There's damage on this stuff. Not all of this is rust. This piece looks okay on the front, but on the back, it's got a little bit more of that rust, but it's not too terrible. I cleaned up the price signs, so now those look much better. I cleaned up these. Remember how moldy and disgusting these were? Now they're nice and good again. Cleaned up the little coin inserts, the metal pieces, and so now everything looks much better. The coin door, I also went ahead and cleaned up. It now looks a lot better. I took the faded sticker off the front of it with some Goo Gone and alcohol. And here's some more evidence that this machine had some liquid damage. You can see there's drip streak marks going down the coin door, and that does not come off when I try to clean it. So obviously it had some damage, but the inside of the coin door and around the borders here cleaned up a lot better than I would have ever thought. A lot of the gunk down here wasn't rust, it was just a ton of dirt buildup. So that looks much better. I cleaned out the inside of the door, I wiped it down, I cleaned all the stuff that was inside the borders of the coin door, so now the coin door doesn't sound like it's scraping against dirt when you close it, so that's much better. I also freed up the coin rejector button. It was totally stuck. I had to smack it with a hammer a couple times to get it to free itself, but that's free now. So in the future, I imagine I'll take apart this coin door again and really make it look good. But I just wanted to get this stuff kind of sort of clean so that we can get on with testing the machine, because that's kind of what I want to do at this point. So I'm still waiting for my rubber kit, and that won't arrive for another couple days, but once that gets here, we can start putting plastics and stuff back on. I'm going to go ahead and reassemble the coin door, and then I think we can start doing some electrical testing. seeing if stuff works right before I plug the machine in. So I'll get started with the coin door and then I'll see what I want to do next. All right, the coin door is now back together and it looks quite a bit better than how it did before. I cleaned up the coin mechanisms. I made sure that quarters passed through them with no problem. I freed up the coin rejection mechanism, so now that works properly when you hit the button on the outside of the coin door. I cleaned up the buttons and the switches that were on here. I cleaned up these things. And so now when we put a quarter into the machine, I'll put it in the slot here on the right. Comes out right where it's supposed to, and it hits that switch. So the game will rack up credits now properly. So obviously I'm still gonna have to clean all the mold out of the bottom of the inside of the cabinet here, as well as in the back box. But before I do that, I wanna turn to some of the electrical components that need testing. There's a little daughter board down here, and I would like to take that out because I wanna test the capacitors that are on it and show you a process called capacitor reforming that we can use to check and see if the capacitors on that board are good. So to remove this board, we have to remove 3 connectors. This one, and this one. And then there are 4 screws on the corner, and then this board should come right off. And with that 4th screw removed, there is the board, free from the system. So let's go ahead and take that board to the other garage and we'll take a look at it and see if things look good on it. All right, for this next section, you're gonna have to ignore the background noise. The hot water heater for my house is currently running, and I would like that to run right now because it's making this garage nice and cool, because today is pretty hot, about 80 degrees, so it's nice to work in a cool environment. So here's the board that we just took out. And from a sticker that I saw inside the machine, I believe this is the soundboard for the game. So I assume that this is responsible for generating the system sounds. In terms of capacitors, we have 1, 2, 3, 4, 5, 6, and then we have several ceramic capacitors on the board too, but I don't think those are going to be a problem. It's these 5 electrolytic capacitors that I would like to check before sending 120 volts to the entire system. So we also have a fuse right here, and it does not look like it's blown. This is the system volume potentiometer right here. And then we have 2 switches. There's a switch right here, and then there's a push button switch right here. I have no idea what those do, so I'll have to look at the manual to see what those are for. So the top side of the board looks good, but a little bit dirty, so I'll go ahead and clean it up before I put it back in the machine. If we take a look at the back, you can see we have some factory bodge wires back here, and it looks good back here as well. It doesn't look like this board has been reworked at all. When taking a look at the solder connections for the fuse, they may need to be redone because it kind of looks like it has some cracks in the connection, so I can go ahead and redo those connections right here. That's very easy. And we can also test the volume potentiometer to see if it's actually working before we power up this board, and I'll show you how to test a potentiometer. So the first thing I want to do is show you how capacitor reforming works. So first I'm going to do it on this big capacitor right here. This is an 8,000 microfarad capacitor, and it is rated for 16 volts. So what you want to do is take a bench power supply and connect each end of the power supply to each end of the capacitor, and you want to make sure you apply a low voltage across the capacitor. And initially it'll draw kind of a high current as it tries to charge, but the current should drop off after a little while, indicating that the capacitor is being reformed. So since this capacitor is rated for a maximum of 16 volts, I'm not going to apply any more voltage than that to it. So I'm going to get you in view of my bench power supply so we can watch the current. Okay, so what I'm going to do is I have the power supply set to 0 volts right now. I'm going to go ahead and hook up the 2 leads to the ends of the capacitors, and this capacitor is polarized. It shows the positive lead on this side, so I'm going to connect the positive lead of the power supply to the positive lead of the capacitor, and hook up the negative lead to the other side. And I'm going to start turning up the voltage on the power supply. That will be shown here, and the current draw will be shown here. So first, let's do a volt. So as you saw, we got a little bit of current there, but then it dropped to 0. So let's go ahead and raise up the voltage. We'll go to 5 volts. Okay, go a little bit higher. There we go, now we're starting to draw current. So we're drawing 411 milliamps right now. So I've left it on 7 volts for a little bit now, and as you can see, the current draw has gone down pretty significantly. So the capacitor is indeed going through a reforming process. It's kind of settled off right here, and the capacitor is not hot at all. I'm gonna go ahead and raise the voltage up to 10. Go up to 12. And now we'll go ahead and put it all the way up to 16. Now, if I wanted to do the reforming process more accurately, I would want to take the capacitor out of circuit by desoldering one of the leads. That's also probably why the current draw is still up there, because I think if the capacitor were to be out of circuit and it were to be fully charged, then it wouldn't be drawing any current. So because the capacitor's in circuit, we might be feeding voltage to other components, which is causing the current draw you see here. So, oh shoot, that's not the capacitor. That was the voltage regulator on the other side of it. And this is a 25 volt rated cap, so we got a good amount of headroom with voltage. So let's go up a bit. Okay, that's basically nothing. 10 volts, good. 15, 20, 25. Looks like this capacitor is A-OK. All right, and just as I thought, every capacitor in this board, in terms of needing to be reformed, is absolutely fine. So I have full confidence that these capacitors are going to work when I power the system on. But I want to do capacitance testing and leakage testing now. So first let's do capacitance testing, because we can do that with this meter right here. So what we should see when we hook up the 2 leads of the meter to both ends of the capacitor is a reading that is very close to what is marked on the capacitor. If it's higher, like by a significant amount, that might indicate that the capacitor is leaking, because when capacitors start to leak, they develop internal resistance, which makes them take longer to charge, and that's why the reading on the meter would be higher. So first let's test this capacitor right here. This is a 1000 microfarad cap, so we should see a reading very close to that. 1.38 millifarad, that's about 1380 microfarad, 1380. So it's possible that this capacitor is leaking because it's reading over like that, or it could actually be measuring higher capacitance than what's rated. We'll get to leakage testing here in a little bit. So that's what that one measures as. This little one right here is a 100 microfarad cap, so we should see something pretty close to that when measuring this one. Go ahead and let the meter update here. 110 microfarad, that one is perfectly fine, so no issues with that one. Let's test the capacitance on this big one. And I don't know if the meter is going to be able to read that one because it's an 8000 microfarad cap, but we'll see. So this one seemed to stabilize around 9.1 millifarad, and that is about, well, now it's at 9.5. That's about 9500 microfarads. So this one, the capacitor's working, but it could be leaky. So that one will also be one to go under test. Next one is a 1000 microfarad cap. We'll give that one a test. 1.45, that seems a little high. That's very close to 1500 microfarad. So that one could potentially be leaky as well, but it seems like they're all testing okay, at least close enough to their marked value. This next one is a 470 microfarad cap. So let's see how this one tests. Okay, we're going up and stabilizing. So that would be about 382, now 400 microfarads. So we're just gonna let this stabilize here for a second. So this one is steadily going up a little bit now. It's not going up in massive increments. And so that's around 502 microfarad. As you can see, it's going up a little bit. That's not too far off from its marking. So I'd say that one is okay, maybe a little bit leaky. But once we get to the leakage test, we will know for sure that the capacitor is leaking. And the last one on here is a 33 microfarad capacitor. So let's test this one. What do we get out of this? 48, 49 microfarad. So all these capacitors are testing close to their marked value. It's understandable that they're a little bit higher because capacitors from the 1970s, they're probably leaking a little bit. And so that's why the reading on these is higher. But none of them are open, none of them are shorted. So we don't have any major faults with these capacitors, which is good. So now what I'm gonna do is I'm gonna go get my capacitor leakage tester and we'll see if these things are actually leaking or not. And this is what we're going to be using to test if the capacitors are leaky. This is a Heathkit capacitor checker from the 1970s. So it's from around the same time as this board. So this is an era appropriate device to test capacitors with. So a word of warning, if you have one of these Heathkit capacitor checkers, they can potentially be dangerous if you don't know how to use them. So I would recommend reading up on how these capacitor checkers work before going and using one if you don't have any experience with them. So just a little word of caution with these. So this is a vacuum tube capacitor tester. So I'm going to turn it on and we're going to wait a minute for it to warm up. You'll see the eye tube right here start to glow. And before you turn one of these on, you want to make sure that it's in the discharge mode with this switch right here, so the middle position, and that is what it's in right now. As you can see, the eye tube has started to glow. The eye tube in this tester isn't the strongest, so the glow is not going to be extremely bright, but it's going to be bright enough to see if the capacitor is leaking. So, because we're testing electrolytic capacitors, we want to flip this switch to the electrolytic position. So this capacitor tester can also do capacitance tests, but it can only go up to 1,000 microfarads. So capacitors like this 8,000 microfarad, you can't test with this thing. But we can test capacitors that are within the range of 1,000, and I think that this capacitor tester can test really small values of capacitors. So as long as we're in the range of 1,000 microfarad and 0.00001, it can test capacitors that small. We can test the capacitance. So let's test, just for the heck of it, this 470 microfarad capacitor. And so to test capacitance, what you want to do is flip this from the discharge to the bridge position. And what you want to do is set the scale on here so that you can get to the 470 microfarad position on the scale. So for this tester, it's going to be the C external scale, and that's what it's set to right now with this dial. So what should happen is once we start moving this, you can see the eye tube is opening and closing. So what you want to do is adjust the eye tube, or adjust this, so that the eye tube is fully open, and that will tell you what the capacitance is. So right now the eye tube is fully open, and then so what you want to do is read what this is set to, and in my view it is a little bit above the 500 microfarad mark. So that would be kind of what we would expect based on what we've seen from the modern capacitor tester multimeter. So that's how you do that. And so before you remove the clip leads from this, you want to put this back into discharge mode. As you can see, the eye tube closed for a minute and then opened again. That was the capacitor discharging. So you definitely want to make sure you do that before you remove the leads. So let's do some leakage testing. We're going to start with this 1,000 microfarad cap. So before you test a capacitor for leakage on this thing, you have to make sure that this thing is set up right. First, you want to make sure that the capacitor you're testing is the right type. So you want to flip the switch to the type of capacitor you're testing. Then you want to make sure that the voltage dial is all the way down. In this case, that's 3 volts. connect your clip leads up to the capacitor, then flip this switch from discharge to leakage. And as you can see, the eye tube is still open. That's good. So now what you want to do is you want to steadily increase the voltage with this knob until you get up to what the capacitor is rated for. And if at any time the eye tube in this thing is staying closed, that means the capacitor is leaky. So right now we're at 3 volts, the eye tube is open, the capacitor is not leaking at 3 volts. So we're going to steadily increase this up to 25 volts. So this is 25, and the eye tube is closed, but I can see it's opening slightly. You can see how it's opening. So now the eye tube is open and we're at 25 volts. So that means this capacitor is not leaking. It is perfectly fine to use. But before you take the clip leads off the capacitor, this voltage dial can go all the way up to 600 volts. So when you have this dial all the way at 600, there will be 600 volts going through those clip leads. So what you want to do to be safe with these things, before you remove the clip leads, put the voltage switch all the way back down to 3 volts, then flip the switch to discharge. See how the eye tube is staying closed? That means the capacitor is still charged. So right now it's discharging. So once the eye tube is fully open, like that, then the capacitor is discharged, and now it is safe to remove the clip leads from the capacitor. I'm going to go ahead and test this big capacitor right here, because that's the one I'm kind of concerned with, to see if it's actually leaky. So let's go ahead and do this one. And this one is only rated for 16 volts, but the closest setting we have on the tester here is 15 volts. So I'm going to go ahead and adjust it up to that. We'll flip to leakage. It's not leaking at 3 volts. We'll go up to 15. Eye tube is kind of in an in-between state right now. It is opening very slowly. But as you can see, the eye tube is opening. So even though this capacitor doesn't make the eye tube go open really quick, the eye tube is now fully open, so this capacitor is not leaking. It is good. So I'm going to go ahead and do that to all of the capacitors, all of the electrolytics on this board, and we'll see if they all pass the leakage test. Well, the final capacitor I test, we have a leaky capacitor. The eye tube is kind of in a halfway open and closed state, and it is not opening. So it's the little 33 microfarad 16 volt capacitor that is leaking. So this one will need to be replaced at some point. So I'm looking at my spreadsheet of all the capacitors I have, and I don't have a 33 microfarad 16 volt. I have a 33 microfarad 25 volt, but it's a surface mount capacitor, so that's not going to work. So I'm going to have to leave this in the circuit for now, but now we know we have one capacitor that will need to be replaced. So I'm going to go ahead and solder all of these back down. We'll put this board back into the machine, and then we'll start taking a look at some of the bigger boards that are in the back box. So what you want to do is put one lead on one of the edge contacts of the potentiometer and the other lead on the middle contact, like this. And then you're going to set your meter to resistance mode. And so right now the potentiometer is reading 0.21 kiloohms. So when I turn the potentiometer, we should see this reading change. So right now, let's turn it all the way down. Now we're down to around 6.87 ohms. So it is working. As you can see, I'm turning it and it is adjusting. So now I turned it a little bit. Now it's at 44 ohms. So now if I keep turning it, you can see the reading is going higher. Now we're in kiloohms. Let's go ahead and turn it all the way up here. This is all the way up, 5.6 kiloohms. So the potentiometer is indeed working. So now what you want to do is take this lead and put it on the other edge contact of the potentiometer. So right here, 43 ohms. Now if we turn it all the way down, it's going to be kind of the inverse of what we just saw. So if I turn it down, the reading should go higher. As you can see, I turned it a little bit and the reading is going higher. Now I'm turning it more. Turn it all the way down, 5.6 kilo ohms. So this potentiometer is working just fine. All right, I'm going to call it here for part 1 because the video is getting a little bit long. So the soundboard capacitors are working except for the one little 33 microfarad capacitor. So I'll have to get that replaced. In part 2 of the Phoenix Restoration series, you're going to see the Playfield after it's all cleaned up. We'll put the soundboard back into the machine. We'll take a look at some of the boards in the back. We'll solder in a new battery holder, and we will get this thing powered on for the first time in 40 years. So look forward to that in the next video of the Phoenix Restoration series. That's all I have for this video. I will see you next time.